From the Autoline Studios, here is your host, John McElroy.
Thanks for joining us on Autoline this week, where the topic is all about 3D printing. If you haven't heard about it, you're going to learn a lot today. If you have heard about it, you're going to learn even more, because I've got three experts to talk about this 3D printing, including David Darbyshire from a company called DASI Solutions, which sells 3D printing machines. Bruce Bradshaw is with Stratasys, a company that makes 3D printing machines. And Brian Levy is with Gibbs Racing from NASCAR, and they use 3D printing machines. And it's great to have all three of you here on Autoline this week.
Thanks for having us, John.
Thank you.
Bruce, let me start with you. For those who don't know, or even for those of us who know a little bit, exactly what do you mean by 3D printing?
First of all, let me say there's a couple of terms that people hear in the industry. One is 3D printing, another one is additive manufacturing, and another one is rapid prototyping. You hear those terms and they're kind of intermixed, so they kind of mean the same thing.
Or even stereolithography, right? It's
That's
sort of part of it.
Kleenex terminology for 3D printing, if you will. So people refer to an SLA as a generic term for 3D printing. But there's many technologies, but essentially what it is, it's extruding a material, a plastic or a metal, depending on your application, or printing it through an inkjet head, much like your 3D printer does at home, but instead of jetting liquid ink, it jets the material that you're going to end up with, and it builds up the part layer by layer until you actually have your 3D printed part. And that's why it's also referred to as additive manufacturing, because you're adding material layer by layer as opposed to subtractive, like a CNC machine that starts with a block and you take things away.
In fact, we should point out to the audience that here in front of us, we've got a number of examples of 3D printed parts. And David, I want to start asking you about it. Is when this all got going, I saw this technology literally going back several decades ago. It only involved plastics, and in fact, only certain polymers of plastics. Looks to me like you can do a whole lot more than that today.
Well, and that is where the industry is going. In the past 5 years, I think we'd have to say that 3D printing is in the material delivery business. And not only can we deliver the plastics that we delivered 20 years ago, but now we could deliver metals, we can deliver rubber-like materials. We could digitally blend these materials together for custom application. For example, here in Detroit, we have automotive companies that manufacture headlamps where they want to have a clear material with a rubber grommet around the outside to seal the waterway. You could blend these materials together a lot like how you'd blend paint. You can blend a yellow paint and a blue paint to get different shades of green. You could blend a rigid material with a flexible material and get different Shore values or different stiffness characteristics for your application.
Now, I understand how you can liquefy plastic and print that out into a solid object. How do you do that with metal?
Well, with metal, you use a laser beam. You basically hit a powderized metal and it changes the melt state and it just bonds to itself in that form.
So is there any limitation on the kind of materials that can be used?
You know, technology is advanced at a very rapid pace, and as soon as these technologies catch up with the materials characteristics, it's all in the new applications.
Okay, Brian, I'm dying to learn. NASCAR and 3D printing, I never knew that the two went together. So tell us what you're using this for at Gibbs Racing.
Yeah, sure. So we use NASCAR. We have to abide by the rule book, but we produce the entire car from the body to the chassis, every part underneath it. So, and it's a performance-driven industry, so we have to stay at the cutting edge to produce the fastest cars week in and week out, so that we can ultimately win races and ultimately win a championship. So
you're constantly changing these cars throughout the season?
It's a continuous development cycle, and rapid prototyping allows us to do that by taking any specific part in the car. We can redesign it in the computer, and before we go to manufacturing, we can produce a plastic version of that part to check form, fit, and function before we produce the metal part that'll go on the car and go to the racetrack. But in addition to that, we can also use the technology to produce interior parts of the car for changing parts on the dashboard that perhaps the driver asks us to modify for them. One of the terms we like to use is rapid customization. So if the driver comes back from the track on Monday and says, I want to move this gauge 3 inches to the right, well, we can produce a new part of the dashboard with that gauge 3 inches to the right, make a model of it in the computer, produce the plastic part, put it on the race car, and send it to the track. And now, 4 days later, that driver has the gauge exactly where he wants and he didn't have to wait 3 or 4 weeks for us to produce molds, to produce a carbon fiber part or a CNC part or anything like that. So it allows us to keep our drivers as happy as they want to be in the car.
So Bruce, that's very interesting. Talking about these different things, I got to believe that there's all different kinds of these machines. Then you need specific horses for courses to borrow a race.
Absolutely. I mean, we talk often about the right tool for the right job, and Stratasys has multiple technologies, and our competitors have similar technologies, but also different. And depending on the application that you're doing, requires a different tool. The fortunate thing about this industry is it's moving rapidly. As Dave pointed out, material development is a huge emphasis for us and our competitors. The machines and the technology behind the machines is changing rapidly. So the amount of innovation that's happening affecting manufacturers in the automotive industry and pick an industry is amazing. And 3D printing and additive manufacturing is at the forefront of it right now.
And David, we've got some examples here. Let's talk about specifically what you can make with these machines, and even more specifically what the automotive industry is making with these machines. And I'm curious about this miniature engine block that you've got on the table in front of us here. Tell us a little bit about that.
I have a really cool success story with 3D printing, and this is kind of like the value of it. How many times have you printed off a Word document that you typed up only to find a spelling mistake? And there's a spell checker inside of it. Well, this engine block basically represents a spell checker. It's very small. We can print out a scale version of the engine block right there. We could pass it around in this meeting. We could look at it. And I have a situation where we had a customer one time take a part that we were doing as a benchmark to see if the technology would fit for their given application. And the engineering director got all upset because the print was wrong. It was wrong. And I'm thinking to myself, no, my 3D printer is right. You gave me the CAD data. We printed it appropriately. It turned out it wasn't until his engineer held it in his hand that he saw certain features were inaccurate. And they had just released the part to go to the foundry. Imagine the money that they save by catching that error in the prototyping phase as opposed to getting those blocks back from the manufacturer.
So it's human nature. We need to have physical objects in us. Just like you say, you print out something on paper and then you find the spelling mistakes.
Yeah. And there's a lot of tactileness to it. When you take a part and you could put it inside of the underhood of a vehicle or put it on a dashboard, you could actually feel it, touch it, get the emotion of that part a little bit better than you can by just looking at it on the CAD screen.
Mm-hmm. And John, there's automotive manufacturers that are using 3D printing for just that reason. Instead of actually doing a virtual 3D print, they print out 10 different versions. They give it to their marketing department. They go do a focus group. Does this handle fit the way you expected it to? So we use the term, a picture's worth 1,000 words, a part's worth 1,000 pictures. So
that's a great line. Brian, talk about some of the products that you got in front of you right there. What are these different things and why did you 3D print them?
Yeah, so a couple of things I have here. This first one is actually a brake pedal that we use in our race cars every single week. And this is a good example of one of the things that we can do with rapid prototyping is, say we want to change the geometry of our brake pedal. Well, it'll take 3 or 4 weeks to produce the metal part, but I want to be able to let my driver sit in the car, see if it feels the way he wants it to if it's comfortable to him, if it affects his foot in a certain way. So I can produce 3 or 4 different versions of this brake pedal, let him try them out, decide which one he likes the best, and then we can go to manufacturing with that. And it completely streamlines the process, and it saves us costs so that we don't have to produce 5 or 6 metal versions of this part on a typical CNC machine. And in the end, we're only going to use one of them anyway. So that's a great use of the technology.
So it's strong enough to test, but maybe not strong enough to stand up in a race or for the rest of the season.
Exactly. The materials that we have available are certainly robust enough that the driver could sit in the car, try it out, see if it feels the way he wants it to feel. And it's a brake pedal, so he can put some force onto it, really put it through its paces a little bit. Not on a track environment, but enough for him to evaluate it as much as he needs to before making that decision to say, so I want option A.
You could slap in different pedals until the driver says, this is the one I want.
Exactly.
So Bruce, we're talking about prototyping and evaluating. What about production parts?
Well, that's actually changing. Folks have heard of 3D printing, and you hear it from a consumer level standpoint. What's going to change now is manufacturing. The ability to actually produce end-use parts, and I think you can ask Brian about another part that he has here. He's got a great example of that. But there's a middle ground that people aren't hearing about because it doesn't have the sex appeal. When I'm Chrysler and I'm designing my next automobile, the same time I'm designing that automobile, I'm designing a manufacturing floor. And there's lots of tools, what we refer to as jigs and fixtures on that manufacturing floor that in the years past had to be either sent out, would take weeks to do, or machined and take very expensive on the manufacturer side. Now I can print it out on my 3D printer and change my manufacturing floor overnight. Makes me much more agile as a manufacturer, and ergonomically for the workers, actually they can produce these much lighter, much easier to use for the workers, so it helps productivity as well.
One thing I would like to interject here, we have customers that are now putting 3D printers on the manufacturing plant floor. And a good example that happened recently, we had one of our customers had a manufacturing operation for an automotive company that was about ready to go mission down. The plant was going to shut down. They had a new device that was going to be used to correct the part on the manufacturing floor, but it was going to take 6 to 8 weeks to have that part, have the injection molds made, and get a limited run device made. And so what they did is they designed the part, they 3D printed it, sent it down to the shop floor, they tested out the design, validated that it was going to work in the manufacturing environment, and then they sent it out for the final hard tooling. But while they were waiting for the finished injection molded part to come to the shop floor, they were already in production and they had zero downtime.
Amazing stories. Okay, Brian, so go back to this other component that you got in front of us.
Yeah, so the other one I have here next to the brake pedal is actually it's a housing for a carbon monoxide filter. Basically, there are 43 race cars on a track at once. There's a lot of toxic fumes out there, but our drivers and every driver out there needs to breathe fresh air, but he needs to not breathe all those toxic fumes in. So we've basically manufactured, and this is an end-use part. We produce about 200 of these a year. They go on the race car, all 3 of our cars, every single week. And basically, it's filled with all the filter elements and the carbon activated charcoal that is used to filter out all those toxic gases from the air, so that all the air that goes to the driver that he's breathing is clean. It's free of any toxic elements, so he can drive the entire race without feeling lightheaded or having any sicknesses because of those toxic fumes. And I think this is a great example of the use of the technology. The geometry in this part, we wouldn't be able to produce if not for the rapid prototyping technology. It would require traditional manufacturing processes that would be super expensive, very complex, very costly in terms of time. And like I said, to produce 200 of these a year, and to be able to use it, discard it when we're done with it, when the filter element is all filled with, filled to capacity, and then to produce another one and to keep the circulation going where we don't have to risk not having these to go to the track next week. It's super valuable having this technology.
So that's not a prototype part. You're actually using those in the race car.
Exactly. This is an end-use part. It comes exactly as it comes out of the machine. We run through some simple post-processing technologies to remove support material, which is just part of the build process. And then it gets assembled with those filter elements like I talked about before, and it gets assembled, installed right on the race car, and then we send the race car to the track to go race. To go
win the race, hopefully, right?
Hopefully.
So is this common throughout NASCAR? Do a lot of the top teams use these 3D printing machines?
They do. It like I said, it's a performance industry. Everyone wants to have the fastest cars week in and week out. And you need to take advantage of that technology to be able to produce parts like this that you couldn't ordinarily produce through traditional manufacturing processes, to develop your lighter or stiffer or more aerodynamic suspension components or body components, things like that. One of the things that we use the technology for pretty regularly is producing patterns for carbon fiber parts. We want to put carbon fiber on the car because it's lightweight. It helps, keep the weight down on the car. But a lot of the geometries of these carbon fiber parts is very complex. So with the rapid prototyping technology, we can produce these complex geometries to produce the male pattern that we can then use to produce molds for producing the end-use carbon fiber part. And just about every single carbon fiber part that's on our race cars starts from the rapid prototyping technology.
So at Joe Gibbs Racing, how many 3D machines do you have?
We have 3 machines right now. We have the Stratasys Fortis 400 machine. We have a Dimension, and we just recently took in one of their Connex 3 machines.
How busy are the machines? I mean, are they sitting there not well used or running all the time?
Never stop running. All 3 of them run 24/7.
That's an interesting point there. With 3D printing, it is a mature industry. This technology has been around for 25 years, but there's been a lot of advances in the machines and the materials that they deliver and how they work. And one of the challenges that I have as a reseller of these technologies is getting the veterans that have been in this industry a long time who think they know what 3D printing or additive manufacturing is all about and showing them what the new machines are capable of doing. When Detroit went through the recession back in 07, 08, capital expenditures were frozen. And a lot of people had 3D printing machines that were lying dormant within their organization. As we come out of the recession, people are taking a look at the technologies, what they have to offer, and they're starting to change their engineering and manufacturing processes. And that's what we try to do here at this partnership, is we try to work with people like Joe Gibbs Racing and say, what do you actually need to do? How can we do it faster? And how can we leverage the technologies that Stratasys provides to our customer base?
Bruce, what is it that's changed? As David just said, this technology's been around for 20, 25 years, but it just seems to me that in the last few years, man, this thing has exploded. It's like generating so much excitement. Was there any one thing, or is it just been building anyway?
I use the term all boats rise in a rising tide, and fortunately for us, a company by the name of MakerBot, which is a Stratasys organization, started the groundswell with consumer-level 3D printers. So there was lots of coverage on consumer-level 3D printers, and they are impacting our lives today, and we see that. But it made the term 3D printing well-known. It's still not understood. I think, as Dave pointed out, it's mature in the industry part of it, but if you go to the person in the back office of this, they know about 3D printing, but they don't know what it's for. The fortunate thing is, President Obama talked about it in his State of the Union address and the impact it's now going to have on manufacturing. And I think bringing manufacturing back to America and bringing it locally based on just-in-time manufacturing for inventory and things along those lines, that's where 3D printing is going to have the largest impact, not only from a economic standpoint, but from an employment standpoint. And so I think the notion of 3D printing has been spawned because of the consumer level stuff, but the momentum going forward, I think, is going to be a lot on manufacturing.
Along those lines, I think is also the skill set of the next generation workforce. You are finding 3D printers not only in universities, but you're also finding them in elementary schools and middle schools. Kids are using these for their first robotics competitions, Formula SAE competitions, and they're coming to the marketplace with a natural skill set, just like using an iPod or something along those lines. They're not going to say, do you have a 3D printer? They're going to say, where is the 3D printer?
And which one is it?
To that point, a lot of manufacturing people think this is how you're going to get a younger generation interested in manufacturing. They have a very negative impression of what manufacturing is about, but they love 3D printing, and they're willing to get involved with that.
Correct.
Where do you all see this going? I'll give you one example. You mentioned MakerBot. I went to the Maker Fair that's held here, and I saw MakerBots, and this was being run by grade school kids, using their MakerBots to make parts for other MakerBots, to make parts for other MakerBots, and I went, this is the future, man. This is where it's going.
We have service responsibility for some of the machines that Stratasys sells, and many of the components of the machines are actually 3D printed. So it's very nice.
So where's this all taking us? Brian, where do you think this leads, especially from a motor racing standpoint?
Yeah, I think the technology is just going to continue to develop, and we're going to find more and more uses for the technology. Right now, on the racing side, at least in NASCAR, the rules don't allow us to produce as many metal parts using additive manufacturing. But I think that's going to change ultimately. I think ultimately we'll be producing components that are now CNC machined out of metal. We'll be producing those using an additive manufacturing technology. Perhaps some of our carbon fiber parts could be produced using additive manufacturing as the new materials continue to be developed, as post-processing technologies continue to be developed. And I think more, like I said, I think more and more parts on the car will be additive manufactured as opposed to just the traditional manufacturing processes.
I know Local Motors is going to be printing an entire car at the IMTS show in Chicago, so maybe that's the future, right?
No, it is. I mean, he referenced stuff that's happening at Joe Gibbs, and I don't think it's that far off where we're going to see the same thing impact consumers. We're all affected by it today because manufacturers are using it for design and some manufacturing. It's not too distant where you're going to either break a handle on your car and you're going to download that part. You're either going to have a printer in your house, or you're going to hit print and you're going to go to your local automotive supply store and pick that part up. And by the way, it's not only going to be the same part, but it's going to have your mom's birthday on it, and it's going to be a little customized for you. So,
and for classic cars, that are out of production, this is perfect.
Yeah, absolutely. I mean, the combination of 3D scanning, to be able to scan a left side of a bumper or a bumper that exists, to recreate that is happening all over the place. There's an automotive show that I'm sure folks are familiar with called SEMA, and if you walk that show floor, what you see for 3D printing is amazing at that show.
Yeah, I think organizations like Mopar made a living customizing a Jeep vehicle, and I think that's what 3D printing is going to allow people to do. The next generation has a better computer skill set that lends itself to doing 3D parametric designs, and they're going to be just hitting print, and they're going to be slapping that on their car.
Now, you mentioned, that this is going to have an impact on manufacturing. I'm wondering, what's it going to do for jobs? I mean, if these 3D printing machines can produce an entire component, is that going to have further impact on manufacturing jobs?
I believe it's actually going to have a positive impact. Again, we talked about, first of all, how much of what's happening now from an automotive perspective is offshore. I think bringing it locally is going to have a huge impact. Will people have to be retrained and learn new skill sets? Absolutely. But I believe this is actually going to have a positive impact because we're going to bring manufacturing back to the local region, and I think those employees will benefit from it.
From an entrepreneur perspective, I think that it's going to knock down the barriers of entry. I think you'll have more boutique car manufacturers coming on the market space, more people that are going to be competitive in designing next fuel rail systems or heads-up display systems or cup holding type systems, because it used to be to buy a 3D printer or an SLA machine, you'd have to invest close to $750,000. Now for anywhere from $2,000 to $25,000, you could put something in your garage.
So you guys deal with the auto industry. Amongst the automakers and suppliers, who's really doing the best job here?
Well, I can tell you from Stratasys' standpoint, the fortunate thing is all of them are utilizing this technology. Just like Brian referenced, all the racing industry folks are using it. The same is true for the automotive industry as well. If you talk high-end applications like Bentley, every Bentley is custom ordered, so they print lots of 3D printed parts in every interior of a Bentley car. But Ford, Chrysler, Mercedes, BMW, you pick the automotive manufacturer, they're utilizing 3D printing. I think the holy grail will be at the end when we can actually do end-use parts in volume for 3D printing.
So if I went in a Bentley today, what might I see? What interior components lend themselves to
the stick shift handle, the radio, the way the panel is configured, the steering wheel,
light rails inside there. You could have you have backlit buttons. You could have floor mats that can be manufactured. And it's not only it's not the final part that's the prototype. Sometimes it's the tooling that's the prototype, because we could basically do a vacuum form process to get the end product. We could print stamping dies in some applications. We could print injection molds and make the final parts. Pretty much it's getting to the point where you cannot tell the difference. And probably the biggest advancement in the automotive departments, if you want to find the market leader, it's the organization that is investing in post-processing and investing in multiple types of 3D printing technologies. You can paint a part, you can polish a part, you can chrome a part, and you would not know that it's a prototype these days.
That's unbelievable, and it's especially interesting hearing that you can use it on the manufacturing floor.
Correct.
I mean, for tools and jigs and fixtures.
Holding fixtures.
Yeah. Dave talked about injection molding. I mean, we talked to lots of folks that need to get parts done now. Problem is, it's going to take them 10 weeks for a tool to be made. Well, they're actually producing the mold on a 3D printer and doing injection molding on that 3D printed mold and getting to market faster while their tool is being created. They also can do tool verification before they go off and spend $60, $70, $200,000 for a tool, they know the part that's going to come out of that tool is real.
Check gauges, Holden fixtures. There's, quite honestly, what we have found the biggest value has been is when we bring the customer into our lab to take a look at all the machines, take a look at all the different samples, and even though that right there is an engine block, they may say, I have a different application for that type of thing. And they run back and they have me sign a non-disclosure.
Of course. Brian, is this what got you into motor racing, or did you get into motor racing and then stumble onto 3D printing?
A little bit of both. Like we talked about earlier, additive manufacturing, it's in the universities, and the university that I attended, is what led me to the job I'm in now. But we had additive manufacturing as part of the Formula SAE program, where we produced parts that went on our race car, using additive manufacturing technologies. And at the time, this was a few years ago, it was a technology that we, couldn't take advantage of as much as we'd like to. And then I move along into the NASCAR industry, and we use it, extensively. And now it's incredible how much, we can take advantage of it.
Well, this has been an eye-opener for me. I'm like some of those other guys that you've run into that said, oh, yeah, I know all about 3D printing. Well, guess what? I didn't know half of much of what you guys all know. I want to thank you all for coming in here today and sharing all your knowledge with us. Very interesting. So, David Darbyshire, Bruce Bradshaw, Brian Levy, great having you all here.
Thanks for having us.
Thanks for having us.
And great for having all of you having tuned in.